Asked in this question to sketch a velocity time graph. And so I'm just going to read the whole thing. We're starting from rest, reaching a speed of 6 meters per second in 25 seconds. Okay, so that's going to be increasing, and then accelerating further, and then decelerating till we come to rest. So all the values are going to be positive or zero. And it only asks for a sketch. It just wants like them labeled reasonably well. So start from rest, increase, let's say to here, and then accelerates further, and then decelerates. So this is 6 and this is 25. And then this is 10. And then this is 150. And we don't know this time here. I am going to write just by it for my own information that A here is 0.05. So that's my sketch. In B, we're asked to find the acceleration during the first 25 seconds. It's a constant acceleration, so we can use that. The initial velocity is 0, the final velocity is 6, and the time taken is 25. So v equals u plus at, but u is 0, so a is just going to be v over t, which is 6 over 25. Probably best to work this out as a number. Not just a fraction, so 0.24. Next up, we're told that the cyclist takes t seconds to decelerate from 10 until coming to rest. So this length of time is t, capital T seconds, and we're asked to calculate the value. So I'm going to get another sketch down of my velocity time graph. And then we're interested in this. So I think what is best is actually working in terms of some other t. Maybe we call it t1 and figuring this out, although actually this won't quite be t1. This will be, let me call this t1 plus 25. Because that will mean that this is t1, and I can actually calculate that using Suvat. So I'm going to look at the time period 25 to t1 plus 25. And I should have said that this is actually 0 to 25. That was the period over which I was using the constant acceleration that I calculated. So now we have that u is 6, b is 10, and a is equal to 0.05. So I can again use v equals u plus at. Difficulty in this question is really just figuring out what you're actually trying to calculate. So 10 is equal to 6 plus 0.05. And then technically this is going to be t1. Oh, sorry, it's just going to be t1 actually, because that's what I've defined it as. So then t1 is going to be 4 divided by 0.05. Actually, that is 400 divided by 5, which is 80. So we've got 80, and this is 105, and that means that t is going to be 150 minus 105, 45. Finally, we're asked to determine the average speed for the cyclist's journey. So the average speed is the total distance traveled divided by the total time taken. We're going to have to find the area underneath this graph. And I think I'm going to, again, draw another, just, you could do it on the same thing, but just to make it clear to you, I'm going to put another graph down. But I'm just going to kind of simplify a little bit. So that was 105. Okay, I don't need any of this. I'm just going to make it as simple as possible. So let's calculate the areas. I'll call this area 1, area 2, and area 3. First one is just going to be a half base times height. So a half times 25 times 6. I can just halve the 6 to give 3. 3 times 25 is 75. 2, I've got trapezium. I could either split it into a rectangle and a triangle or just use the formula for trapezium. It's the two parallel sides added together. So 6 and 10, then divided by 2, times that by the height, which is 80. So 16 divided by 2 is 8. 8 times 80 is 640. That's our larger distance, and probably the largest distance. Then 3 is again a triangle, so it's going to be a half times, okay, remember this was 45. Half times 45 times 10. So 450 divided by 2 is probably the easiest way of doing it, 225. Total distance traveled is going to be the sum of these. The 225 and the 75 combined to give 300, so it's just going to be 940. And therefore the average speed is 940 divided by 150. Which gives 6.26 recurring, or to three significant figures, 6.27. That looks about right, doesn't it? Because it goes up to 10. It's 6 for above 6 for a long period of time, and in between it's less than 6.